Qwen can fit on a high-memory workstation after quantization. Kimi's official deployment example uses H200 data center GPUs. So before we ask which model is better at coding, there is a more basic result. Only one of these is realistically local for an individual developer. Both models publish downloadable weights. That tells you who can inspect and host them. It does not tell you whether your machine can hold them, how fast they run, or whether the local version behaves like the hosted service. This is an evidence audit, not a hands-on benchmark. I traced the claims back to official model cards, public benchmark methods, and independent studies. That shows us what each model has actually demonstrated and where the evidence stops. Kimi K2.7 Code is a 1 trillion parameter mixture of experts model. 32 billion parameters activate for each token, and the context window reaches 256,000 tokens. It is built for long coding sessions, tool use, and repository scale work. Qwen3-Coder-Next has 80 billion total parameters and activates only 3 billion. That is roughly 1/12 of Kimi's stored weight and less than 1/10 of its active compute, while keeping the same 256,000 token context window. Here's the trap in every mixture of experts headline. Active parameters influence compute per token. Total parameters still have to live somewhere. A model that activates 32 billion parameters can still require hundreds of gigabytes because the entire expert library must remain available. A 4-bit Qwen weight estimate begins around 40 gigabytes before runtime overhead and cache. That is demanding, but plausible, on a 64 gigabyte or larger workstation. Kimi's own guide starts with 8 H200 GPUs. Open in principle is not local in practice. For real repository bug fixing, Qwen has the cleaner public evidence. Its technical report records 70.6 to 71.3% on SWE-Bench, verified across 3 different agent harnesses. Those tasks come from real GitHub issues and are graded by tests. But even Qwen's own report shows why one score is never the whole product. On terminal bench, the same model moves from 25.8 to 36.2 depending on the agent harness and tool format. Change the wrapper, and the model appears 10 points smarter. Moonshot reports a serious upgrade. Kimi Code-Bench rises from 50.9 on K2.6 to 62 on K2.7. Program Bench rises to 53.6, and Moonshot says the model uses about 30% fewer thinking tokens than K2.6. Those are useful results, but they do not create a clean victory over Qwen. Kimi Code-Bench is Moonshot's internal test. The published K2.7 evidence does not include a neutral, same harness SWE-Bench run against Qwen3-Coder-Next. Different exams cannot produce one honest ranking. Kimi's best case appears when the job becomes an agent workflow. Moonshot reports 76 on CP, Atlas and 81.1 on CP mark verified. Those tests reward choosing tools, recovering from errors, and completing multi-step work across real services. That matters, but it is not the same as repairing a repository. An agent can select the right database tool and still write a bad regression test. It can navigate GitHub correctly and still misunderstand the product requirement inside the issue. Qwen's published portfolio is broader. It reports strong bug fixing, competitive terminal work, 60.6 on English full stack bench, and 66.2 on Ader's multilingual editing test. The pattern is credible coding efficiency, not universal dominance. For a real bug, Qwen gets the evidence advantage. We have multiple SWE-Bench results across real repositories and multiple harnesses. Kimi may be better, but its K2.7 card does not publish the equivalent neutral repository result needed to prove it. For front-end work, the answer splits. Kimi accepts images through its official API, so it can inspect a reference screenshot directly. Qwen has public full-stack evidence, but no native vision in this model. Neither source gives us a fair same-design comparison. Refactoring is where benchmark confidence becomes thin. Repository repair scores show that both families can navigate code and edit multiple files. They do not prove that either model preserves every undocumented contract while making the design cleaner. The honest verdict here is insufficient evidence. Test writing has the same problem. Passing generated tests can mean the tests are useful or merely agreeable. Without mutation testing or hidden defects, coverage is not proof. none of the published headline numbers establishes which model writes tests that catch failures humans did not reveal. An independent study tested older Kimi and Qwen generations on one React Native application. The benchmark rankings did not predict the artifact that actually shipped. The older Kimi produced the most complete app. Qwen produced clean code, but misunderstood the per-day behavior. That failure is more useful than another leaderboard. The clean code ran, authentication worked, and user data stayed separate. But the model built one running counter instead of a daily history. Every file looked competent while the product requirement was still wrong. The study is also honest about its limits. It used older models, one prompt, one seed, and one application stack. It proves that concrete artifacts can overturn benchmark expectations. It does not prove that today's Kimi beats today's Qwen. There is one more layer. Most developers do not run these weights themselves. They call a provider. Research on hosted open models shows that latency, throughput, context, caching, reliability, and even protocol behavior can change across services carrying the same model name. At official short context list prices, Qwen starts around 30 cents per million input tokens and $1.50 per million output. Kimi lists 95 cents for uncached input and $4 for output, with a much cheaper 19-cent cached input rate. Run Qwen locally and the token bill disappears, but the cost does not. It becomes memory, electricity, setup time, slower generation, and a machine large enough to hold the quantized weights and cache. Local is ownership, not free compute. Kimi changes the scale completely. H200 GP, user not a developer workstation. They are infrastructure. Calling that model local without naming the hardware is like calling a database local because a company can install it in its own data center. If local means a model an individual can realistically own and run, Qwen3-Coder-Next wins. It is dramatically smaller, has an Apache license, supports the common local runtimes, and has stronger public evidence for fixing real repository issues. If local does not matter and the job is a long, tool-heavy coding session, Kimi becomes the interesting bet. Its scale, mandatory reasoning, multimodal input, and vendor-reported agent scores are compelling. But the independent same-harness evidence is not strong enough to call it the universal winner. So is there a new number one? Not one that survives every definition. Qwen is the practical local coder. Kimi is the ambitious, hosted, open-weight agent. The model you should choose depends less on one leaderboard and more on the repository, the harness, and the hardware you actually own.